Hello everyone, welcome to Coders Camp. So today we are the 12th day of May LeetCode challenge and the problem we are going to cover is range sum query 2D immutable. So the input given here is a two-dimensional matrix and we have to implement two functions. First one is num matrix where we have to initialize our data structure here, and the second method is sum region and which is used to calculate the sum from particular submatrix and return the value. So let's understand this problem with an example. So here is our given input matrix and the coordinates of the range we have to calculate the sum in our second method sum region. So in this example, we need to consider the sum of this particular submatrix and it sums up to 11, which is nothing but 6 plus 3 plus 2 plus 0. So now if we are approaching it in brute force way, then we have to iterate the given number of rows and columns and add each value and return the result. And that is going to take big O of m into n time complexity where m and n are the number of rows and columns given in the submatrix. So in this case, our second method sum region is going to be the often called method. So every time you want to calculate the sum of a submatrix, it is going to take big O of m cross n time for each operation or each time you call the function. And that is going to take too much time and which result in time limit exceeded. So how are we going to approach this in an optimal way? So we are going to use the same logic we have used in one of our previous videos, that is the submatrix sum equals to target. So consider our array is not a 2D and it is 1D. In this case, we are going to calculate the prefix sum of our given array. And it looks something like this for this given example. Prefix sum is nothing but sum of a range that is starting from 0th index and till that point. So 3 plus 1 is 4 and at index 2 the sum will be from starting from 0th index till the index 2, and at index 3 the sum will be from starting from 0th index and index 3, same way till it calculates the sum to the last index. So what is the advantage of having this prefix sum? For example, if you want to calculate the sum from the range 2 to 1, that is from index 2 to index 4, then in that case it is sums up to 2 plus 4 plus 1 equal to 7. So by using prefix sum, we don't have to iterate through that range and calculate. Instead, we can easily calculate by the sum at that particular index subtracted by the range's previous index. That is, we want the sum from this index to this index. So we are going to take this sum and subtract it from the previous sum. That is previous sum till that index. So that we'll get that value easily. So we are going to apply the same logic to our 2D array to find our sum. So here is a given example input array. We are going to calculate the prefix sum at each row of this given matrix, and the sum at each row is going to look like this. That is, we simply added the sum at each row considering it as a 1D array. So in this case, now we have our sum ready. How are we going to calculate the sum of a particular range? For example, we are going to calculate this particular submatrix's sum. So to calculate, we are going to iterate through the given range, for example, row by row. So by first row, we are going to calculate the sum in that row alone. That is, the sum of these two cells are going to be value at this index subtracted by the previous sum or sum till the previous cell. That is going to give us 9. And then we are going to move to our next row and then subtract it in the same way. That is 3 minus 1, which is going to 2. Now overall the sum of all the rows iterated gonna give us the sum of that particular submatrix. So we are going to apply this logic to find our result. So in our first method to initialize our data structure, we are directly gonna have a DP array which is gonna store the prefix sum at each row instead of storing the actual matrix. So this is going to take big O of n time complexity as we are going to iterate the given number of rows and columns. And when we call our second method, it is going to iterate through only the rows or the number of rows given in the sum region parameter and return as our result. So that is going to take big O of m time, which is nothing but the number of rows given. So as many times we're going to call, it is going to take big O of m time for each operation. So let's go to code now before getting into the most optimal solution. So as I said, I'm going to declare a two-dimensional array DP to store our values. So inside my num matrix, I'm checking the basic conditions. So I'm going to iterate my given rows and columns and calculate prefix sum at each row. So yes, we have iterated our rows and columns, and at each row comma column we have added the current value plus the previous value in the previous column. So now our matrix is ready with its prefix sums, and in our second method, let us initialize a variable sum equal to 0, and we are going to iterate the given number of rows, that is the row 1 to row 2. And at each row we are going to calculate the sum. And finally return sum as a result. So yes, coding part is done. So let's run and try. Yes, let's submit. Yes, it is accepted. So how do we do it in a even more optimal way? So in this solution, we have seen it is taking big O of time complexity, as it is going to iterate every row in the given matrix. And we did actually a caching technique where we have stored the pre-computed values for our use. So how do we do this caching in a even more better way so that we can take only big O of 1, that is constant time, to access the values? So here is a given matrix. So this time, instead of calculating prefix sum at each row, we are going to calculate the sum to the overall range. That is, we are going to calculate submatrix wise, and the sum looks something like this. So this is nothing but, for example, the sum at this particular cell, let's say 14, is nothing but from 0 comma 0 till that particular cell 6. The overall sum for this particular submatrix will be taken from here. Same way, if you consider 26, which is nothing but from 0 comma 0, the overall matrix sum will be present here. So this way we are going to calculate and make our matrix ready in our first method, that is num matrix itself. So how do we do it? For each cell, its sum will be at its previous column and its previous row. That is, for 14, it is 8 plus 3 plus the value at the current cell, which is 6, minus its diagonal cell 3, which actually gives us 14. So how do we say that? Because here 8 is nothing but the sum from 0 comma 0 till this particular row. Same way 3 here is nothing but from 0 comma 0 till this particular column. So here the overall sum will be the sum till this row and till this column plus current value. But why are we subtracting minus 3? Because while calculating from 0 comma 0 to that particular column, we are considering 0 comma 0, that is 3. Same way, while calculating column wise, we are again considering 3 twice, 2 times, while row wise as well as column wise, we are considering this common cell twice. So in that case, we have to consider that sum only once. So we are subtracting it from the overall sum once. Hope you are understanding this concept, and by using this concept, we are making this array ready in our num matrix method. So what are we going to do in our sum region method? So once we pre-computed the cumulative sum of a given matrix, we are going to calculate this particular matrix's sum. So how do we do it? So as I said, each cell here represent the overall range of sum from 0 comma 0 till that particular row and column. So in this case, we have to subtract this particular submatrix alone from that range. To do that, we are going to take away the sum of this row and this column from this overall sum. So which is nothing but from 21, which is the overall sum, we are going to negotiate or subtract the previous rows. How many ever rows from 0 comma 0 till that range. So that is going to be 4, because we have calculated the overall sum till here, till that range. Also, we are going to subtract how many ever columns previous to that particular range. So in that case, from 0, 0 till that range, the sum was in the previous cell, which is 9. So why do we add 3? The same technique we have seen in our previous step. That is, this 3 has been considered in both row wise as well as column wise. That is the sum till that range. So we are adding that because since it is considered twice, we are subtracting it in this range itself. We have to add it once and calculate the sum. That is going to give us the sum of that particular range. So what is the advantage of using this method, though it is pretty difficult from the previous method? Because while calculating this cumulative sum, again it is going to take one time of big O of m cross n. And while retrieving the value by using this method of calculation, it is only going to take big O of one constant time. And how many ever times this function is going to be called, it is going to take only constant time, and that reduces a lot of time. So hope you're understanding this solution. Let's go to the coding part. So I'm not going to change much of my code. So instead, I'm going to change only 2 lines. Here in my DP, instead of DP of R comma C plus 1, I'm going to calculate row plus 1 and column plus 1 is equal to DP of previous row or previous cell in row wise plus previous cell column wise and the current cell's value minus the common cell which we have considered twice. So that's it. This will have the cumulative sum instead of the prefix sum. So in this case, here in our sum region, we don't have to really compute the sum at each row, but simply I'm going to return dp of so this is nothing but the overall cumulative sum at that particular cell, that is 2 comma 2 or the row 2 comma the column 2, minus we have to delete the sums in the previous rows. So in this case, dp of row 1, that is till before that range, and column 2, and we have to subtract the columns in front of that range. So to do that, dp of and we have to add the common sum which we have included in both the subtractions. So yes, that's it. We simply going to compute the value and return it in constant time. So let's run and try. So yes, let's submit. Yes, the solution is accepted and runs in 10 milliseconds. So thanks for watching the video. Hope you enjoyed this walkthrough. And if you like the video, hit like, subscribe, and let me know in comments. Thank you.